I know in class and probably in previous videos, I've hinted around the importance of molecular shape, which brings us to the topic of isomerism. So let's just, as a review, remember that molecular function is largely determined by molecular shape. So isomers are molecules, two molecules that have the same exact chemical formula, but actually have different structures. A lot of people unfamiliar with chemistry, especially organic chemistry, assume that if you know a molecule's molecular formula, you know everything there is to know about it. But two substances can have the same molecular formula and have totally different structures. And if they have different structures, they have different functions. So they're not actually the same substance. So let's take a look at the three types of isomers, beginning with structural isomers. Structural isomers are those substances that simply have completely different shapes. Same formula, totally different shapes. So if we look here we have glucose and fructose. Glucose is C6H12O6 and so is fructose. And if you look at both the top and the bottom figure in each case, you can see that each of them can exist as either a ring-shaped structure or as a linear structure. And even when they form rings, they don't form the same shape of rings, and they don't form the same shape of linear structures, because if you see that double bond oxygen, it's not in the same place in each case. And so that change of position with that oxygen is what accounts for the totally different shapes of glucose and fructose. So while these have the same chemical structure, they have completely different shapes. They're not the same molecule at all, and they are structural isomers. Simple enough. Geometric isomers are a touch more complicated. In geometric isomers, we have substances in different positions across a double bond. Usually we focus on hydrogen, but I'm going to show you a couple examples here. Let's focus on retinol. Here we have a retinol molecule, and notice in our retinol molecule, it can exist in either the bottom bent form or the top straight form. Either way, it's C20H28O, but it's in two different conformations. And the key here is to look at these hydrogens. In the bottom picture, we have a double bond between two carbons, and the hydrogens are on the same side as each other. In the top figure, the same exact carbon-carbon double bond has the hydrogens on opposite sides. So even though we have the same things on either side of the double bond, in general, the fact that they're in different positions, what we call cis when they're on the same side as each other, or trans when they're on the opposite sides of each other, they're not the same molecule. We have two differently shaped molecules with things arranged differently across a double bond. They exist as either cis or trans. And finally, we get to stereoisomers, or what are also called enantiomers. Here, the molecules are mirror images of each other. This one really messes with people because they look so similar that people don't think they're necessarily different. Let's take a look. Here are two pyramids, two mirror images of triangular base pyramids. And now I'm going to overlay some molecular structure onto this. So here's our molecule. We have a central black with a red, blue, orange, and white coming off it. And here we have the same, what seems to be the same molecule, but they're mirror images of each other. I'm going to remove the pyramids now and just leave the two molecules there. These are not the same molecule because the different colored groups coming off of that central black atom don't have the same properties. Different properties in different positions means different molecules. And if you're looking at these going, oh, I'm not convinced they're not the same, let's just rotate the molecule on the right. Let's rotate them and see if we can get them into the same position. So if we rotate it a little bit, I want you to notice things are not in the same position. And I'm going to keep rotating it. And no matter how I position it, the atoms are not in the same position. These two are mirror images of each other. They're not the same. Think of these like left and right hands. Left hands and right hands are mirror images of each other. They're not the same. They have all the same parts, but they don't fit together the same way because they are mirror images. All molecules that have different structures with the same chemical formula are called isomers. And make sure you understand this concept of isomerism because it can pop up many places throughout the course.